One of the things we talk about is artificial application. This is the way humans put it down. This is a Case International Harvester Nutriplacer. You can see that it has little spacers out on the booms. The little spacers cut down into the soil and lay down a certain amount of fertilizer, be it liquid fertilizer or a powdered form. This particular setup is going to use a liquid fertilizer. When we talk about fertilizer, here's a bag of fertilizer that's sold in Florida. It's got these three numbers down on the bottom, 12, 0, 12. 12 is for nitrogen, 0 is for phosphorus, 12 is for potassium. A lot of fertilizers sold in Florida does not have phosphorus in it because most soils in Florida are not deficient in phosphorus. Phosphorus is one of the problems you will get in waterways that will cause excess growth in the waterway. How do we put the fertilizer down? This particular one is a little bit different because this is going to be the injection of anhydrous ammonia. Anhydrous ammonia is basically ammonia gas that is placed down in the moist soil. When it is put in, it instantly reacts with the water to give you ammonium hydroxide, which is going to cause an increase in pH. It's also going to supply nitrogen. There are a lot of different types of nitrogen that you can buy. You can buy the synthetic inorganic types. These will give you a rapid initial response in plant growth. When we say rapid, we're talking within 24 hours. There's no breakdown needed. These are things that you put down, they solubilize into the soil, they are picked up fairly quickly by plants. You also have a short residual. When they are picked up rapidly, they are used rapidly. They are depleted rapidly out of the soil. You get a short residual in it that's not staying. It's got to be used up. They also tend to leach because they're all soluble. They're soluble in water, which means anytime you have excess water and the water is draining through, it's going to take some of this nitrogen with it. We have the chance for a high foliar burn potential. These are soluble salts. You put too much soluble salt on something, it starts drawing the material out of it, and it's going to create problems. You have a high foliar burn potential with these. A lot of them are nitrates. All forms of nitrate are water soluble. Here's a series of forms. You've got ammonium sulfate, you've got ammonium nitrate, sodium nitrate, calcium nitrate, ammonium chloride, anhydrous ammonia. Your nitrogen content varies from 15.5 on the calcium nitrate, which is a kind of a low concentration, all the way up to 82% on the anhydrous. The anhydrous is nothing more than nitrogen in a soluble form. They put the anhydrous down, the ammonia reacts with water to give you ammonium hydroxide. We have organic sources of this. Now, depending on where you're at, it may be possible to get these organic materials. You may find them in the fertilizer. Basically, they are byproducts of some sort of industry. If you look at sewage sludge, when you flush the toilet, it goes down to the sewage treatment plant. There is a certain amount of material that is left over. They got to get rid of it somehow. There is one city in Wisconsin called Milwaukee that pioneered taking of this sewage sludge, activating it or digesting it, drying it down, bagging it up, and they sold it as organic fertilizer. People buy it all over the place. When you do that, they have got a real market on this stuff. They're selling you the material that they want to get rid of, telling you it's got nitrogen and other things in it. If you're looking at dried blood, animal tankage, these come from slaughterhouses. When you slaughter the animal, one of the first things they do is they bleed the animal to get a lot of the blood out of it. That material gets harvested. It is rich in nitrogen, 12 to 14% nitrogen. It's got a little bit of phosphorus, a little bit of potassium. If you dry that material down, you can then use it as a soil amendment. Animal tankage, same scenario. When they slaughter the animal, there are parts of the animal they use. There are parts that they don't use. Parts they don't use are called tankage. It goes in with a certain amount of water. The tankage can be ground up. It can be dried down, or it can be sprayed on in the field. It will add nitrogen. Bone meal. Out of the slaughterhouse, you've got all these bones. You grind it up, you can use bone meal. Some people like bone meal as a fertilizer. It's got some phosphorus in it. It's got some calcium in it. It's theoretically pretty good for the plant. You've got fish meal, byproduct of the fishing industry. Horn and hoof meal. This is a byproduct of the slaughterhouse. Cottonseed meal. Harvest the cotton. You take the cotton, you thrash it, you remove the seed from it, then you take that seed, you grind it down. You can get cottonseed oil out of it. What's left over after that is cottonseed meal. Soybean meal, corn gluten meal are the same scenarios, only you're doing it with soybean or corn. Castor pumice is the same sort of material where you take the seeds, you squeeze the seeds, you get the oil out of it. What is left over is called castor pumice. That material can be used as a fertilizer. Things like soybean meal and corn gluten meal, they can also be turned into types of food. We've got nitrogen. These are organic sources. These are byproducts of some sort of industry. We've got sludge. One of the problems with sludge is it may have cadmium in it. They have to make sure that the cadmium is removed from it. It comes out of the process of taking the sewage, treating the sewage, and trying to process the sewage down so that you can get the water back out of it. All of sludges are slow release, much slower than inorganic forms of nitrogen. They need microorganisms for release of the material or soil weathering. They need time and a little bit more time over that because they are not going to be rapid. Here's your picture of Milorganite. Milorganite is used a lot of times in the turfgrass industry. It's a very good material. It says it's non-burning, no need to water in. It gives you a deep green. It's got 4% iron in it, and it's got 100% organic nitrogen. People look at it and go, whoa, it's organic. This particular bag says it covers up to 2,900 square feet. We've got synthetic type nitrogens. These can be either water soluble or water insoluble. These are created in a factory. Water soluble types include things like urea. Urea is 45% nitrogen. Urea, it's not gotten out of the sewage treatment plant. They actually chemically created in a factory. You've got calcium cyanamide. This is a calcium with a carbon and 2 nitrogens on it. It's 22% nitrogen. This is water soluble. We've got the water insoluble types, which include urea formaldehydes. These will have up to 38% nitrogen in them. They're water insoluble. They are slowly available, which makes them very nice because rather than having to go out multiple times into the field to be able to put your fertilizer down, you only need to go out once. You can put it down for an entire 6-month time period. You've got cold water insoluble ones. You've got hot water insoluble ones. A cold water insoluble one might be soluble in hot water. Hot water insoluble one, they're going to be even slower release than that. That's okay, but you put it down once, it stays around for a long period of time. Cold water soluble, 25% of a fertilizer, you get immediate use out of it. So if you're going to make a fertilizer, you want to use some cold water soluble, you want to use some cold water insoluble, you want to use some hot water insoluble. Then you're going to be able to get a blend out of it because what the blend does or the mix does is it treats it now and it treats it 3 months from now. If you put down only that which it can pick up in the next 24 hours because it's readily available, you don't want to put much down. If you're using it to put down where you've got it over a long period of time, then you're going to put down a mixture of these materials. It's going to be slowly released into the lawn. There is a tremendous cost in applying fertilizer, so therefore you want to try and minimize the amount of fertilizer that you have to put down. You do this by creating a mix. When we look at fertilizers or nitrogen sources, there are a lot of different types we can use, a lot of different sources we can get the material from. You use what is available, but you got to have sufficient amounts of nitrogen.